Okay, welcome to your in-class lecture on scientific notation. You guys have just gone through CER and experimentation. Now we're going to take a look at how do we represent numbers, okay? Because there's actually a science behind it. And remember, numbers are technically models. So how do we represent or model our values? And really, actually, our precision is the end goal. So, scientific notation, the purpose of it is it's a style of writing or representing very large and very small numbers. So how when you were in like what, kindergarten or something, do you ever remember, maybe not kindergarten, maybe third grade, do you remember ever like making funny numbers with like 0.000000016? And then you'd make it the number big and you'd have fun and be like 6 0 6 7 0 0 0 0 0 0. And then you tell your friend multiply it, add it, right? Well, we get numbers like that in chemistry, and especially because when we talk about the particulate level, when we talk about the microscopic level, and we try to scale up to the macroscopic level, you're going to get a lot of zeros to get that scale up. So suddenly now we're working with giant butt numbers, and giant butt numbers are really annoying to write. So what we do is we create a text lingo, a little bit more quiet in the peanut gallery. We create a text lingo, right? Instead of saying be right back, we say BRB. Well, instead of saying this giant butt number, we do a scientific notation number. We keep the meaning, we keep the value, we change the look. Okay. So Avogadros number is a great example of this. This is a super important number in chemistry. It's actually the number of things in a mole. You're going to learn what a mole is, to be determined. I'm going to tell you that in unit 3-4. All right. But a mole is essentially a number counter. And the value of Avogadros number is it helps us scale up atoms and particles, individual atom particles, to a point where we can talk about it at the macroscopic level. Here's why that's necessary. None of you guys go around and say, hey, could you get me a particle, a single molecule of water to quench my thirst? Right? You're like, no, can I have like a cup? Do you know how many particles of water are in a cup to quench your thirst? You don't want to count those. Let me tell you, you'll be writing zeros forever. So what we do is this is actually the expanded notation, the actual value of Avogadros number. It's 6, 0, 2, 2, 20 zeros after that. That's the mass of that's the amount of scale up that we have that Avogadros number offers us. Count your 20 zeros after that final 2. Imagine if I made you show your work using that. Liam, are you following along? Are you AirPods should be out by now, by the way, guys, because now we're in lecture. Thank you. Thank you. It's short and sweet. Good. You got your expanded notation? Okay. So what do? Well, we turn it into scientific notation. Scientific notation looks like this. We turn that number into 6.022 times 10 to the 23rd. To keep the value, we count how many powers of 10 we have to preserve. We just don't write all those powers of 10. We don't write all those placeholders, but they are there. So what we say is to create a scientific notation based number, we turn any number into a number between 1 and 10. So we turn 6022 into 6.022. And then we count how many decimals we need to move the original over. How many powers of 10 we still have to maintain in order to keep the value of the number. If it is a positive exponent, you know that you move the decimal over for a very large number. It's a positive. If it's a negative exponent, power of 10, you know you moved it for a very small decimal. So for the first one, I assume most of you feel rather comfortable with this. So I'm just going to do one example and you can do the rest, okay? And then we'll confer as a class. I have this number. I'm going to turn it between a number between 1 and 10, so 4.77. And I'm obviously not going to write zeros if it's just a trail of zeros. The whole point is to get rid of that need to write all the zeros. And I'm just going to simply count my decimal would be at the end. I'm going to move it over 1, 2, 3, 4, 5, 6, 7, 8. I moved my decimal over 8 times to make it a number between 1 and 10. But I don't want 4.77 because that's not the true value. So I'm going to acknowledge that I had a power of 8, okay, a 10 power of 8, okay? And that is my scientific notation compared to the expanded notation version. or the original notation version. So go ahead and do the following 2 sets of practice problems and be prepared to share your answer. I'll give you about 1 minute. What's the next one in scientific notation, going from expanded to scientific? Okay, I do not want to include the O or the 0 because the whole idea is that we get rid of excess zeros. So it's 9.1 times 10 to the negative 4th. Now honors, this will look different for you. If I ask you to do a certain sig fig, you might need to do include the 0, but that is an honors topic. You'll know what I mean once you get there. But for now, the idea is to get rid of those excess zeros. So we're gonna do 9.1 times 10 to the 4th. Moved your decimal over 4 times. I definitely drew that funny bunny. Okay, you moved your decimal over 4 times to get it to a number between 1 and 10. Excellent. Let's do Devin. Let's do expanded notation, from scientific to expanded. Oh, so we're going from scientific now. What was the original number? Reading scientific notation now. Oh, I see how that was confusing. No worries. So I originally had my decimal here in scientific notation. This already is in scientific notation. Now I want to ask you, okay, what does this really mean? Expanded notation. What's the actual value? Because sometimes it's hard to know the value in scientific notation. Well, we'd move it over because it's a positive number. We make it a bigger number. So we're moving it in the direction to make it a bigger number. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to have 6, 3, 0, and 7 more zeros after that to give me this value. And that's where the new decimal is. Okay, right? The implicit decimal. Now, honors, again, sig figs. Decimals change everything for you. It's a very tedious first honors topic. Very tedious. AP kids score the lowest on this quiz for sig figs. Yep, that's what I'm saying. Okay, Abby, do you want to do the next one for me?
Is it 6 zeros before?
Excellent. So the decimal was originally here. We have a negative exponent, negative power of 10. So we'll just move it over 6 times, but making it a smaller number. So 1, 2, 3, 4, 5, 6. Okay, and that's how we get that value. Let's go ahead and this other practice. Let's do Jessica. Three. Four additional zeros in front. In terms of before the after the decimal. 1, 8, 7. Okay, next one, 3, 7, 1, 2, 3, 4, 5, 6, 7. That's your value. What is that? 370 million. This one, 78.8. We just moved it over once, right? And then 2164 times 10 to the negative 2. You moved your decimal over, now making it a smaller number, 0.02164. Okay, so this is your first workbook topic. So what do we mean by workbooks? Remember, for homework, it's 5% of your overall grade. I do random workbook checks, so I'm not always going to check your workbook. But for the most part, any topic you learn in class or honors online, there are practice problems for you, like guaranteed, okay? So what you would do is you'd go to either Canvas to download, or you go to my website to download the workbook. And you go to Unit 1, honors, don't forget about your little secret tab to find the video in PDF. You'd go to Unit 1 and you download my workbook. Okay, this first page is dedicated to what you've already know, scientific notation and unit conversion stuff, metric prefix. All right, maybe you're actually not here. Maybe this is just getting you familiar with the metric prefix. Either way, you can do page 1 pretty much, okay, for the weekend. Here's my deal with workbook problems. One, again, I don't check every single day. I check randomly. If you miss the check day, you're sick or you just weren't ready, totally fine. Submit proof that you did that homework that day into Canvas and I'll still give you the point, okay? You don't have to do every single problem, but here's my thing. If you don't do every single problem, you better test pretty much perfect on the test. And if I know that you didn't do every single problem or you didn't even try a problem and you failed that section of the test, I will not give you the option to do corrections because you decided that you were fine. You were fine. You didn't even test yourself. Okay? So that's your decision. That's your consequence. That's my response. Now, if you're someone that's like super familiar with this, do 1 to 2 of them just to show me that you confirmed to yourself that you know what you know. And then when I look around and I'm like, hey, why don't you do all of them? Just say, I'm very confident. I know how to do this. I'll be like, okay, I'll give you the homework point. Honors. In the workbook, you will have, starting Monday, specific honors section. Honors. Sig figs is such a crazy topic. You have 1.5 pages worth of practice. Okay. But here's the thing. A lot of people go, wait, is this an honors topic now? No. Look, it's a heading. It says honors. The moment you get to the next center heading and it doesn't say honors, it's back to everybody. So please, 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 please don't pull a lazy eye and just be like, oh, the rest is honors. It's worked in between topics. Okay. So that's kind of your homework, is doing some workbook problems unless you're really, really confident. And of course, feel free to send me your practice test, your practice CER. I can give feedback anytime. No worries, no problem. I might be a little slower this weekend because I have personal things going on, but otherwise, really good job, you guys. First week done.